solving a system of equations using augmented matrices. So first we have a system of equations. We've got 3x plus 4y equals 1 and x minus 2y equals 7. So our first step is to write the system of equations into an augmented matrix. Now that simply means on the left side we use our coefficients, 3 and 4 for the first equations, 1 and -2 for the second equation. And then on the right side we have our constants, 1 and 7. You'll notice the vertical line. All that does is separate the coefficients from the constants. Think of it as the equal sign within the matrix. Now, remember the goal. When you are solving a system of equations using augmented matrices, the goal is to manipulate the matrix into the form where the left side coefficients become 1, 0, 0, 1. On the right side, our m and n simply represent numbers, right? They're constants. As we manipulate the equations, our constants will change, and this helps us find the values of x and y. So we have our augmented matrix. From there, let's simply start by switching row 1 and row 2 because we notice that row 2 currently has a 1 in the first position. We know our goal is to have a 1 in the first position of row 1. So we can just switch those. That's not a problem. And now we have completed our first step, which is getting a 1 in the upper left-hand position. Now, we have that piece, so let's move on to the next step. We're going to multiply r1 by -3. This gives us an equivalent equation. That gives us a -3 in the first position of row 1, which when we then add to row 2, will make that go away. So if I multiply through row 1 by -3, I get -3, +6, and -21. So you'll notice when I add row 1 and row 2 together, that is going to give me a new row 2. However, we are going to keep R1, our original, right? Row 1 is going to stay the 1, -2, 7. Now when I add row 1 and row 2, I end up with 0. Then 6 plus 4 is 10, and -21 plus 1 is -20. So I have my new augmented matrix here after we start manipulating. All right, next step. We now look at our row 2. We have a 0 in the first position, which is great, but we want a 1 in the second position of row 2. Well, to go from 10 to 1, we simply divide by 10. So if we divide row 2 by 10, it will give us that 1 in the second position. At this point, row 1 stays the same, 1, -2, and 7. When I divide row 2 by 10, I now have the line 0, 1, and then -20 divided by 10 gives me a -2. Row 2 is now exactly where we want it. We have a 0 in the first position, a 1 in the second position. So now we have to work back to remove that -2 from the second position of row 1. So we're going to do that by multiplying row 2 by 2, just giving an equivalent line here in row 2. That will get that the second position to be a +2. So when I add my new row 2 to row 1, it is going to eliminate that second position. So we are going to keep row 2 the same, the 0, 1, -2, but now we're going to add to get our new row 1. So when I add, I get 1 plus 0 is 1, -2 plus 2 is 0, and 7 plus -4 is 3. My row 2 stays the same of 0, 1, -2. We are now exactly where we want. Our coefficient side is 1, 0, 0, 1, and now we have constants. So this tells us that x equals 3, right? First position of a 1 means x, so 1x is 3, and then the second position is y, so y equals -2. If I go back to my original system of equations, I can substitute those values in to check our answers. So first, in row 1, I have 3 times x, which is 3, plus 4 times y, which is -2. That simplifies to 9 minus 8, which is 1. It's exactly what it should be. Second equation is 3 minus 2 times a -2, which simplifies to 3 plus 4, which is 7. Therefore, because both of those check out, we know our answer is correct, and 3, -2 is the solution to the system of equations.